So we're going to do two things from the yellow packet. Then we're going to do selected questions in the ACT, okay? So this deals with trigonometry. It appears on the test for sure. It's on our first page of the notes for trig. And what you have to remember for trig is that acronym, right? SOHCAHTOA. SOHCAHTOA, SOHCAHTOA. And in a right triangle, the side opposite the right angle is called the hypotenuse, right? So in terms of these, you know, S stands for sine, C stands for cosine, T stands for tangent, right? So this is how we can kind of remember what's what. The H is our hypotenuse, O is an opposite, A is adjacent, stuff like that. So we're going to do a couple of questions right off the bat and see if we can like recognize this.
What page are you on?
We are page 17.
Okay, thank you.
Let me write it up here so you have it. So page 17. And it's when it says trig relations. It's somewhere towards the middle. So here we have, and the figure shown below, a ladder 15 feet long. Well, first off, whenever I see a picture, I look at the picture and see if I can do the answer. But I notice they're not telling us anything. Like if you look at the one next to it, see how they have all three things? What do you want to find out for X? It's a little easier to figure out that's what they want us to know. Here, they're not telling us that, so that's making it a little bit more difficult, but not too bad. We're told the distance along the building in feet between, here we go, the ground and the top of the ladder is equal to which of the following? So from the ground to the top of the ladder, this is X. So they want us to figure out what X is. And if I glance at the answers, I notice I see some trigonometry and some weird answers, but it's using this information. So what I do is I start with my angle and I start with the SOHCAHTOA. S stands for sine, right? Sine is opposite over hypotenuse. Let's see if that works. The sine of 56. Well, opposite is the X. The hypotenuse is 15. Hey, that's when it takes care of both of those. It must be sine. If we had thought it was cosine, which is adjacent over hypotenuse, adjacent would be here and hypotenuse is there. That's not the two sides they're giving us. Same thing with tangent, right? Tangent's opposite over adjacent. Opposite, adjacent, those are not the two sides that we're doing. So it's got to be sine. So I'm going to write down here the sine of 56 equals opposite over hypotenuse. It equals X over 15. Okay. Just like cosine is adjacent over opposite. So this is my equation, but I got to solve for X. So I think we're just going to multiply both sides by 15, right? 15's cancel. There's our answer. 15 sine of 56. There it is, H. And that's like, you know, in that middle 20 questions of the test. Not the first 20 or last 20, but the middle 20. Pretty good. All right, let's do another one. It's very, very similar. Notice it's also in the 20s. Given a triangle here, which of the following expressions is equal to X? So here's X, here's the angle, here's another side. So I'm going to go SOHCAHTOA again. SOHCAHTOA. So if I think it's sine, sine would be opposite over hypotenuse. Can't be sine. Let's try cosine. Adjacent over hypotenuse. Nope, it's not those. Hopefully it's tangent. Tangent of 35 is opposite over adjacent. That's what it is. The tangent of 35 is opposite over adjacent. Now, just like on the other one, we've got to go ahead and solve for X. I'm going to multiply both sides by 10. 10's cancel. There is our answer. Letter K. Okay, so those two are pretty like nice introductory questions. We'll see some other ones in here that are kind of similar. 22 is a bit of a stinker. Usually, like, you know, the beginning part of the test, like the first 30, they're not too bad. This one's a stinker. Sometimes you encounter these. So we're told one angle and two sides, right? So they're giving us an angle and giving us two sides. If I look at the answers, there's nothing but A's and B's. This looks complicated. It's not too bad. They want to know, what is the sine of alpha, or of theta? Well, here's our angle, right? We know that the sine of that angle has got to equal opposite, which is here, right? over the hypotenuse, which is here. They don't tell us that, but don't we know Pythagorean theorem? Don't we know that if I call this side x, wouldn't I know that x would have to equal, or wouldn't I know that x squared would have to equal a squared plus b squared? Isn't that our Pythagorean theorem? Square the two legs equals the square of the hypotenuse. And to get x by itself, wouldn't I square root both sides? So isn't this side really the square root of a squared plus b squared? And that's what makes this one a bit of a stinker, because that's really kind of testing some knowledge on you, right? I mean, that's a lot right there. That's a Pythagorean theorem and a trig question all in one problem. And no numbers, all letters. So we get the right answer and we walk away. We're like, man, thank goodness. Okay, we are not going to do number 4, all right, but we are going to look at number 53 at the bottom, because this is another one. It's, now notice it's number 53, right? You're like, oh my gosh, it's back in the test towards the end. And they're asking for what's the area of a triangle. Well, I think we remember that the area for a triangle, isn't it always 1/2 base times height? Isn't that how we find the area? And in this triangle, I think we would all agree that the base is 13, right? This is the base. Now the height is is the perpendicular distance, right? This is the height. I don't know that. So I'm going to call that side x. Now, if we look at this, we will notice that there is a right triangle here. And I could do Pythagorean theorem to come up with this, right? 13 squared plus x squared equals 12 squared. I could also do trig. And so what I might do here is I might say that the tangent of 30, right? The tangent of 30 is opposite over adjacent. I could have said I could have said instead, I'm not going to do tangent. I'm going to do sine. I'm going to kind of mix it up a bit. The sine of 30 is x over 12. Now, we get to use our calculator on the whole thing. Those of you that are in pre-calculus, hopefully you remember your trig and you remember that the sine of 30 is 1/2, but you can use your calculator, right? So if I multiply both sides by 12 here to cancel this out, I have 12 times the sine of 30 is an x, or in other words, the sine of 30 is 1/2, and so 12 times 1/2 is 6. So this side here is 6, so it's 1/2 times 13 times 6, which is 39, I believe. If you forget the half, you get 78. Now, I'm curious, there is another way to get this to be a 6 without doing this stuff. Does anyone know it? Remember from geometry?
Triple numbers.
Yeah, expand that a little bit. Can you explain that a little bit more?
Is it like a 3, 4, 5 deal?
Oh, I see. You're thinking of like those Pythagorean triples. No, this is like one of those special triangles. You remember like one of them was, remember the 30, 60, 90 triangle? And the deal was whatever the hypotenuse is, the side opposite to 30 is 1/2 of that. And then the longer leg is that number times the square root of 3. Is one of those special right triangles you had to know in geometry. And if you don't remember it, if you're in Algebra 2 or pre-calc this year, you'll be doing it a lot. And so I could see this is 30. So opposite the 30 has got to be 1/2 of the 12, which is 6. That's another way to get it. So what I like about this one, there are a lot of ways to come up with the answer. But the deal is, when we see area, write down the formula for area. Put down the things you know, and you're like, okay, how do I get that height? Now, I do want to show you another way to get it without it. Remember I said things are drawn to scale? Well, I'm trying to figure out how long this is, right? So if I were to make some marks on a piece of paper, that distance there, that's the distance I'm trying to find. Well, lo and behold, it's exactly half of the other side. So I could use like my bubble sheet to kind of use it as a pseudo ruler to come up with that also. Nothing wrong with that. ACT does want you to estimate some answers, and things are drawn to scale, even though they say they're not. We've talked about that. So
Mr. Flynn,
yes, go ahead.
I have a TI 83 plus, like a really old calculator.
You typed in sine of 30 and you did not get
Yeah.
1/2?
I got like a -11.
Yeah, you're in radians, which is what we want math always to be. So let me show it on my calculator here too. So to do that, what you want to do is you want to press the mode button, okay? And you'll see, now my window's a little bit different than yours after pressing mode, but do you notice that as you scroll down here, you see radian or degree? You want to make sure you're on top of degree and press answer. So for the ACT and physics, everything's in degrees. In math class, we like things to be in things called radians. It's kind of like Fahrenheit and Celsius. They both say the same temperature, like 32 degrees Celsius is the same thing as, I'm sorry, 32 degrees Fahrenheit is the same thing as 0 degrees Celsius. They describe the same temperature, just different scales. So if you were to change it to degree and then type in sine of 30, see how we get 0.5 now? So just be aware of that. I want to make sure you're in degrees. Let's turn the page and do some more trig here. Oh, go ahead.
Can you show us how to put one of these equations like in our calculator fully?
Sure, like this one?
Yeah.
Oh, absolutely. Yeah, that's why we're here. Okay. So I'm going to type in 12, right? And then the time sign. Now, to get the sign, you've got to press the sign button, right? It looks like sin. It's not sin, it's sign. I press that, and then I type in the number I'm taking the sign of, 30. Now, you can either close the parentheses, which is above the 9, or not. Either way, it'll give you the right answer. Now, did anyone not get 6? All right, so we're all in degrees. That's good. Now, so that's 6, and ACT is nice that they're not listing 6 as an answer. I could see someone selecting that. And then you just, put the 6 in for the height and just type that in, 1/2 is the same thing. I could just type it in 1 divided by 2 is a half, right? And then it's times 13 and times 6. So times 13 times 6. Or I could have said 0.5 times 13 times 6, right? However you want to type that in.
Oh, Mr. Flynn, another question.
Please.
So for like time's sake, when like you're taking the test for 26 and 20, like in the top of the page.
Okay, hold on a second. Yeah, I see it.
Yeah, because you already see, like, you already know that you're trying to look for a sine and you're looking for tan. Wouldn't it be better to, like, you see the answers and you're like, well, there's only one answer with sine, so I don't even have to do anything. I can just circle that.
Oh, yeah, you could. I've only seen one time, that'll be fine as long as the angle here is still 56. Here's one thing. I saw ACT do a question like this, not for very long, but once in a while. So this angle is 56. That means this angle here is 34. And they said, they did, how do I want to say this? 34 is here, X. They did the cosine of 34 equals X over 15. And so they said X equals 15 times the cosine of 34. So what's your idea? It'll work. Just make sure that the angle is the same one they're dealing with, right? Not a different angle. Because if they use the other angle, then you got some confusion. This was just when I saw ACT do this one, like, oh my gosh, please stop doing that. It's hard enough as it is. Are there other ones you want to talk about before we move on to the next page? Okay. So this next one is combining some geometry. It's number 19. It's a bit of a stinker in those first 20. There's no picture. And it says, which of the following is the sine of the smallest angle in a right triangle with side lengths 7, 24, 25. Well, that's one of our triples. I'm going to draw a right triangle. Put my right angle in there. Now, remember, the hypotenuse is always the biggest side, right? So it's got to be the 25. These other two sides, it doesn't matter which one's the 7 and which one's the 24, okay? I'm going to put the 24 here and the 7 here. So question, who remember, if I call these angles A, B, and C, which angle's the smallest and why? It has something to do with the sides.
The angle directly across from the 7.
You got it. The smallest angle's opposite the smallest side. Just like the biggest angle is opposite the biggest side. And that's something that's mentioned in geometry, but not used a whole lot. So this question's taking that idea and can you draw the picture? And do you remember how to do sine? And again, if you just remember SOHCAHTOA, you'll remember. So we have to find the sine of angle C. Well, the sine of angle C is opposite over hypotenuse. So there's like 3 concepts integrated into this one question. But yeah, smallest angles opposite the smallest side, biggest angles opposite the biggest side. All right, I want to give you guys 20 seconds to do number 16. Okay. Jay, that's not too bad a question, you know. As long as you remember SOHCAHTOA, you've got it. All right, let's look at a couple more trig questions here. 44 is probably like my favorite trig question out there because there's so many things in here. They're asking you, what's the tangent of angle A? And you see angle A here and you're like, wait a minute, there's no triangle here. So in geometry, we draw things called auxiliary lines. We need to draw a line in here to make a triangle. And that line we're going to draw is right here, B to D. Now, students have a hard time drawing these extra lines, okay? So the way I knew to draw it is because we're asked to find the tangent of angle A, and how do I find the tangent of something if it's not in a right triangle? Because right now, I do see a right triangle. It looks like that's a right angle. We'll prove it though. Does anyone know what this side is? If we look at the triangle on the other side here, it's a triple. What number is that?
5.
Yeah, 5. And do you see the other triple here? 5, 12, 13. That's pretty cool. It's got 2 triples in it. You got to draw an auxiliary line and you have to do trig. It's my favorite problem. There's so many things in here. Now, tangent, that's opposite over adjacent. So opposite is 5 and adjacent is 12. 5 over 12. Not too shabby. Okay, the one next to it, I think the way it's laid out is a little confusing. They're asking for the tangent of theta and you don't see a triangle. But if you all draw a vertical line segment here, see, this point tells us everything. Like the 10 is the x value, right? So from here all the way to here is a distance of 10. The 4 is the y value, right? It's a distance from here all the way up. That's a distance of 4. Well, tangent, opposite over adjacent. Well, opposite is 4. Adjacent is 10. The answer is 4/10. I don't see it, but it does reduce to letter D. Okay, that's not too bad. We're going to skip 24 because it's just like number 16, just finding the tangent of an angle. But let's look at number 31. This one's kind of interesting, and people that are taking pre-calculus will start seeing a lot of this stuff around December. We're trying to find the sine of n, but they tell us something. They tell us the cosine of L is 7 over 16. Well, isn't cosine adjacent over hypotenuse? So here's angle L. So that means the adjacent is 7 and the hypotenuse is 16. Because see, the cosine of L is adjacent over hypotenuse. Now I've put that information in. Let's see if we can answer this. What's the sine of angle N? Here's angle N. The sine is opposite over hypotenuse. Oh, 7 over 16, which is letter C. Some people, they put this in and then they try to find this missing side and doing more math than they need to. But this kind of gets you to a theorem that the sine and cosine of complementary angles are the same. You don't need to know that. Just put the numbers into the picture and work it out. Let's do one more trig question. It's on the next page, and I want to look at this one, number 46. Now, 46, there's a lot of reading in here, and this is a part like where they've got like 4 questions all going with the same piece. So I'm going to ignore all this. I'm just going to look at the question. It says, what is the tangent of the angle formed by ray CD? So I'm going to draw a ray CD and CE. So CT. Well, do you all see the right triangle there? And I'm like, well, how tall is this? That's the difference in the y values, right? This is 3. How long is this? That's the difference in the x values, which is 2. They're asking for the tangent of this angle here, right? Because it's the angle formed by these 2 rays. Well, tangent is opposite over adjacent, 3 over 2. So this was like just a matter of, drawing the picture to try to come up with what the answer is. All right, I'd like to do some geometry stuff because that's the one thing people are kind of worried about a bit. And it's a couple more pages back. It's on page 22, right? So I'm going to write at the top here, page 22. And it's parallel and intersecting lines. And so my question to you is, if I were to draw 2 parallel lines right here, and a transversal cuts across, would you agree angle 1 would be the same measurement as this angle 1? Like, could you imagine, like in your head, like picking up these 4 angles and just kind of sliding them over so they go on top of it? These 2 angles are the same measurement. Just like angle 3 and this angle up here to be the same measurement. And then of course 4 and 2 are the same, and they're also the same as those. That's that parallel line stuff. It's called like alternating interior angles, alternating exterior, all that stuff. We don't need to know any of those. We just got to find the angles. So like, here's one. They're telling us on this question here that P and Q are parallel. Figure out what X is. Well, this angle here is 32, right? Just like I was able to take these angles and slide them on top, wouldn't this angle 32 fit right inside of here? They're the same exact measurement. They're corresponding angles. They're in the same place. And then we notice that these 2 angles together form a straight line, right? We can see that. And so they have to add up to 180. So if I subtract 32 from the 180, I'm going to get 148. And you'll notice this is like question 20, right? It's not too bad. So that's the basic idea. Then it starts getting a little more interesting, like this one, right? On this question, they're telling us that this side and this side, whoops, are parallel. And then they also tell us something else. Isosceles, which means 2 sides are equal. And in fact, they tell us these are the 2 sides that are equal, right? There's that congruent symbol that someone mentioned the first day. Well, I'm going to mark those 2 sides as congruent, so I have it. Now, these lines are parallel. if I extend this line a little bit, do you see how this angle here and this angle down here, they're going to be the same measurement. They're alternating interior angles. So if that's 32, so is this one. And if the two sides are equal in the triangle, so are the two base angles. So if that's 32, so is this one. And then again, here we see this straight line again. So I'm going to take my 180 and subtract 32 from that. And I'm going to wind up with letter K, 148. Okay. Let's look at the one down here, number 19. They give us a figure and they say, what's the measure of angle ABC? Now, do you notice that the question mark is in the picture? So one of the strategies for math is if you see the question mark in the picture, try not to read, try to go right to the problem. We're trying to get that one. Now, I do notice a triangle here. Does anyone remember what all the angles in a triangle add up to equal?
180.
Yeah, 180. So I already know this angle is 90. So I'm going to subtract 90 from that. All I have to do is figure out this one. Well, they're not telling us these two lines are parallel, but they sure look like they're parallel, don't they? And in fact, see how these two lines they both make a right angle with this line, CD. And when that occurs, that means that these two lines are parallel because they're both perpendicular to a third angle. Also, if you look at the picture, they look parallel as well, and that's okay to do. That means if this is 132, well, so is this one, because we can kind of take this angle and it just kind of slides up and fits right on top of that. And then here we see that straight line again. If this is 132, then the angle inside's got to be 48, because remember, these two angles have to add up to 180, right? Now notice, do you see 48 as a choice? So be careful, don't settle for that halfway answer. You want to get the answer they're asking for, which is angle B up here. So I better subtract 48 from this. And I wind up with 42, which if you read Hitchhiker's Guide to the Galaxy, that's the meaning of life, is 42. Okay, what other ones I want to talk about here? Parallel lines are kind of going okay for you all. Let me give you if we turn the page, let me give you all, this is page 23, by the way, Michael Jordan's number, page 23. I want to give you all 1 minute to work number 10 out, okay? Number 10 is a bit of a stinker to be that early in the test. Okay, about 20 more seconds here. Okay, so this one's kind of weird, because you got to find this angle here. But the key to this number 10 is I happen to see a triangle here. And I know that if I add up all three angles in that triangle, I'm going to get 180. Well, if this is 103, this has to be 77, right? Because they make a straight line. If this is 132, this has to be 48, because again, they make a straight line. And if I subtract those two angles from 180, I wind up with 55 degrees. So this one's kind of weird because we're not told these lines are parallel. In fact, if you look at them, they do not even look parallel, right? So it's a little bit different than that. Okay, last question with this parallel line business here. Supposedly the toughest question on the test, number 60. It's the last one. They tell you that angle X is between 180 and 360 degrees. And you can tell angle X starts here and goes all the way. They're telling you angle Y is here. And they also tell you that X equals 4 times Y. Man, does anyone have any idea of what to do here? It's drawn, the picture is creating a lot of problems. If something else was like how much is this angle right here? Does anyone know what this is? Like, what could I write here for this angle measurement? Think vertical angles. Like if I had two angles here, if this angle's 30, so is the other one, because those were, I'm sorry, Sebastian?
The other side is Y.
Yeah, that's the key to this whole question. These two angles are vertical angles. In Canada, they actually call them opposite angles. It's kind of weird. They call them opposite angles in Canada. But if they had this as Y instead of over here, I think this would be a much easier problem, because we would know that if I took angle X and added angle Y to it, I would have a complete circle. X plus Y would be a complete circle. If you're a skateboarder, you know that's 360. And then they tell us X is equal to 4Y. So I'm going to change that X to be a 4Y instead. And then I just solve this equation, right? Divide and I get 72. Now I do see the answer, but I do need to be careful. Oh, good. They're asking for what the value of Y is. Thank goodness. Okay. So Y is 72. They could have been sneaky and asked for what X was. So this one, it stumps people. You know, they're like, well, how do I do this? Oh, so this is making sure you know vertical angles. And it's written out such that it makes it a little troublesome. Okay, let's do some math on the ACT now. And I want to try to teach you guys some other skills in there. So go to section number 2. And I would like, we're going to jump around on the ACT this time. Let's see, I want you to find number 23. It's on page 19, okay. Here we go. It's on page 19. So we had done some stats yesterday, right? Could you all find the median, please?
Where are we?
Oh, okay. So this is page 19, and it's the same ACT test that Mr. Williams was using. You know, I think when we do this again, we're going to number every single darn page in this book here. Are you better, Naomi? Are you okay now? Oh, no.
Yeah.
Okay, good. So remember, to find the median, you got to list all the numbers in order. I'm just going to mix it up and go from the highest to the smallest. Doesn't matter. You just got to put them in order, right? And then we just got to find the middle number, right? Oh, there's two numbers in the middle. But I think the middle of those would be 87, right? So that was a stat question I saw on this test. Another one I saw was question number 26. So it's the next page. No, it's just on the other side, right here. And we had done one like this a couple days ago when we did probability, right? The bag's got 16 red. I'll write that down. 16 red, 7 yellows, and 19 greens. How many additional red marbles must be added to the 42 already there to make the probability of red being 3/5? Well, we better find out what this decimal is, right? So use your calculator. 3 divided by 5. That's going to be 0.6. Right now, the probability of drawing a red marble, remember it's favorable over total, so it'd be 16 over the total of 42 marbles. And if we divide those out, 16 divided by 42, well, I didn't bring my, oh, there it is. That's going to be 0.38. That's nowhere near, right? And I think the strategy we talked about was, let's try the middle number first. Let's try adding in 37 marbles. Okay, that's the middle one. And if that's too many marbles, well, then we also know that 42 and 52 are still too many. It makes the guessing a little bit easier. So let's try 37. That means that the probability of drawing a red marble is going to be, we're going to add 37 red marbles to this. And that means the total number of marbles also increases by 37. And if we add these up and divide them out, we get about 0.67, which is just a bit too big. So I can safely eliminate those choices. And now we're down to a 50-50, and that's less than a minute, right? Since we were really close, I'll bet it's 23. So I'm going to try that out. I'm going to try 23. The probability of drawing a red marble now is going to be, well, we had 16 in there, right? Let's add 23 red. And that means the 42 marbles also gets increased by 23. And when I divide those out, we get 0.6. So the answer must be letter G. Okay. So, wow, that's like 3 times we've seen that question. So that's pretty good. That's not too bad. I want to show you a technique that you probably are not aware of. And it's question number 56. So it's towards the back of that. It's right here, number 56. And this technique is called plugging in values. And it's a really great one. They're asking which of these graphs could be the graph of this thing. By the way, A is bigger than 0, B is bigger than A, and C is bigger than B. That's really hard. So we're going to pick numbers. Someone give me a number for A. First person. What do you want A to be? And no decimals.
7.
1.
I heard 7. What's B have to be then if A is a 7?
4.
4. Okay. No, B's got to be bigger than A. Tricked you. Because is this
8.
8? Okay, we'll make that 4 and 8. And then what's C got to be? 10. Okay. We just picked these out of the air, right? And nicer numbers would have been like 1, 2, and 3, but I'm not judging. So I'm going to put those numbers in for the A, B, and C. So A is a 7, so we have 7x plus by, which is 8y, is less than or equal to 10. Well, I want to graph this, right? So don't we have to solve for y? So wouldn't we subtract 7x from both sides? So that's a negative 7x, and that's a positive 10. And then wouldn't we divide both sides by 8? And we have this. Now, we have to remember something, right? Remember that y equals mx plus b business from algebra? M is the slope. Our slope is negative. Well, choice F, that's a positive slope. Can't be that one. The rest of these have negative slopes in them. The B is the y-intercept, right? Our y-intercept is positive. For this graph, there's the y-intercept. That's negative. Nope. Here's this graph here. This y-intercept, it's negative. Can't be that one. And then the last one is it's less than or equal to. So that means the shading is below. There we go. It's called picking values and plugging them in, right? I've got another one that uses that same technique. And this one's a tough one too. You want to plug it in. It's number 42. Okay, it's right here. I'll let you read that a bit. Now, anyone that's in, well, you probably need to be in calculus because you have not covered this in pre-calc yet. This is really tough. You know what? Let's make it easy. We're going to pick a number. We're going to pick a number. Now, x is between 0 and 90. I chose x equals 30. Okay, that's what I chose. They want to know which of the following expressions is not equal to the sine of x. In other words, which one is not equal to the sine of 30? Well, I use my calculator, and the sine of 30, when I type it in, is 0.5. So I got to figure out which one of these is not equal to 0.5. Well, I just use my calculator, right? The negative sine of negative 30, guess what? It's 0.5. If I type this into my calculator, the sine of negative 30, that's going to be negative 0.5. Hey, that's the answer. I'm not going to bother checking the rest, but all I do is I change all the x's to 30 and see which one of these gives me an answer that's not 0.5. Now I picked 30 because I knew sine of 30 is a nice number of 0.5, but you could have picked like 10, whatever. You've got your calculator, right? You're typing them in. Which one gives you the same answer? This is utilizing a property that sine is a odd function, but you know what? We don't need that. We can just plug in numbers and come up with the right answer, and it works beautifully. All right. I'd like for us to use our calculator to come up with some other answers. This test had a lot of really great calculator questions, like number 53. I'll let you read that one for a bit. Anyone remember natural logs? Yeah, this is a tough one. I've done the algebra on it, but they want to know when these two lines intersect, right? In other words, when do these two problems equal themselves? That's what they're kind of asking. When does the natural log of x minus 2 plus 3 equal to 7? Because when they intersect, that's what happens. Well, you could do some trig and solve it. I mean, some logarithms and solve it. But instead, what I want us to do is if you've got your graphing calculator ready, I'd like for you to get it out, okay? And what I want you to do is press the y equals button, okay? And if you've got a bunch of things in here, just press the clear button on each line to kind of clear them out if you have some things in there. And what we're going to do is we're going to go ahead and we're going to graph this left side, which is just a 7, right? So I'm just going to type in the number 7, and I press enter, or arrow down, it doesn't matter. And then I'm going to type this bit in. Now, natural log, right? That's what these two letters stand for, the natural log. The natural log is located right by the 4. Okay, you see that natural log? That's what those two letters stand for. So I press it, and I get natural log. And then I go x minus 2, close parenthesis, plus 3. Okay. So I'll wait while you type both those in. Okay, now before we graph this, we should press the window button. Oh, not window, I'm sorry, my fault. Press the zoom button, it's in the middle there, press zoom, and choose standard. That's just gonna make it go from -10 to 10 and -10 to 10, makes it a little bit better here. So there's our first side, the 7, and here's the other one. Ooh, I need to make this window go further out. I think these lines are gonna touch. In fact, they have to because I look at all the answers. So what I do is I press window, and right now my X maximum value is 10. I need it to go further to the right. So let's try making it a 40 instead. So it's gonna go further to the right. Let's press graph and see if that does it. Yeah, see how my graph is going farther now to the right? All right, gotta go a little further. So I'm gonna press window again, and I'm through messing around. I'm gonna put in 100. Heck with this. Let's really make it go out there. And I press the graph button. All right, I think those lines definitely cross. We can use the calculator to find it. It's pretty nice. What you do is you press the second button, right? It says second. Press it, and then press the trace key. That gives us a calculation, right? So again, what I did was I pressed the second, and then I pressed the trace key, which is calculate. And of these choices, I think we want to find intersection, because that makes sense. And all I do is I ignore the directions, just use your arrows, move over to where you think the lines cross, don't read anything down here, and then press the enter key 3 times. All right, so I'm going to do that too. I'm going to press the enter key 3 times. 1, 2, 3. It tells me the X answer. The answer is 56.59815. All I have to do is figure out which of these answers is the same as this. Now, I don't think 6 is the same thing as that. Let me type this, so I got to go second quit to get out of here. I got to type in this e to the 4th, and e is kind of weird. It is on the natural log button. Do you see in blue above it? You see e to the x. So I have to press second and then press the natural log button to get that. So it's e to the 4th power, arrow out of the power and choose +2. Enter. Hey, that's the same decimal answer. That's it. Using the calculator to get it. Now, I did work this one out using algebra. So let me show you the algebra way, because some people are like, I want to see the algebra. If you want to do the algebra, you got to solve for x. So you would subtract 3 from both sides, right? That would give us this pink statement here. And then we've got to rewrite this logarithm statement as an exponential statement. And some people have a hard time with that. And then we've got to add 2 to both sides. I think it's much quicker to do this, this graphing idea to find the intersection point and then start typing in answers and seeing, you know, which one gives me that answer. Okay. Let's see, that was 53. Let's look at, okay, we already did 42. Let's look at 30. Yeah, okay. Let's all go to number 35. Another calculator question. I'll show you how to do the algebra on it in a second, but let's use the calculator to get the answer first. Because ACT really doesn't care how you get the answer as long as you're not cheating, right? And you can use the calculator in the whole test. It says, what's the value of this? Well, let's just type the darn thing in the calculator. ACT thinks that your calculator will not do, this is number 35, by the way, it will not do a base 2, but you know what? It does. They just didn't know it. If you, on this calculator, you guys, so it has to be like an 84 silver or above. If you just have an 84 plus, it won't do this. And I'll have to show you how to get the answer, okay, using another way. But if you've got a TI 84 or TI 83 silver, one of those, if it's just an 83 plus, it won't work. But if you guys press the alpha button, okay, and then press window, you'll see like this secret menu. And if we choose this one, number 5, see how it gives you, you can type a number in the base now? I can put a 2 right there. Arrow over, put in the square root, and put an 8 in. And that answer is 1.5, which I think is what this is. Now there's another way to get that log base also, and that's if you press the math button, okay? And I think you've got to arrow over to number, and no, that's not it. Oh, okay. So another way to get that, I mean, it's so much easier to go alpha window and get it, but another way to get it is to press the math button, and if you scroll down a bit, you'll see log base right there. And again, it's the same thing, let you type it in. Now, if you don't have a calculator that does that, here's what we need to do instead. I'm going to rewrite the problem. Log base 2 of the square root of 8. We're trying to figure out what that equals, right? So I'm going to call that x. So what we have to do is rewrite this from a logarithm to an exponential. So the way to do that, the base is 2, right? So I'm going to say 2 to the power of x is equal to the square root of 8. Now, from there, the fun is just starting. We're going to rewrite that 8 to be a 1/2 power. I mean, sorry, the square root to be a 1/2 power. And then we're going to rewrite the 8 to be 2 to the 3rd power. And then we got to remember that a power to power means we times. And then there we see it, x equals 3/2. I think we all are in agreement that just typing it into the calculator way faster, right? So again, I'm trying to show you ways to get the answers in less than a minute, and also being able to use your calculator to come up with some of these answers, right? That one's not too bad. Let's see, where's another one here? Okay, go to number 33 if you would. It's at the bottom of the other page. Now, above it though, this is one of those grouped questions, right? Like here it tells you, here's our stem, and it asks you a bunch of questions, and then it kind of draw a line to help you remember it. You know what, below here, the grouping is done. But we want to look at number 33. And they want to know, which of the following is equivalent to this? Well, shoot. How about we just type it into this, not the stupid, it's a good calculator. Let's just type it in. 8 to the 2nd power times 4 to the 0.5. So times 4 to the 0.5. All right, there's the answer, 128. I don't see it, but let's start typing in the other answer choices. How about 2 to the 7th? Oh my gosh, there it is. Calculator, super fast. Now, I will show you the algebra way also, because I do want you to know that. So what I could do is I could change this 8 to be 2 to the 3rd, because that's what 8 is, right? 2 times 2 times 2. And I can change this 4 to be 2 to the 2nd. See, the deal is you want to try to get it so these bases are the same number. And we remember that a power to a power means you times. So 3 times 2 is 6. And it's times 2 to the, okay, 2 times 1/2 is 1. And then you got to remember your exponent rules. When you multiply, don't you add the power? So 2 to the 7th. That's not bad, but calculator is a little bit faster. Little bit faster. How are we doing so far? Everyone okay? It's so weird teaching online with this that it just like, I don't get those facial recognitions as much. Okay, we did that one. Okay, did that one. Let's see what else I want to talk about here. Oh, yeah. This one. Okay, can you all turn towards the back of the test, number 52? Now, generally speaking, those last 10 questions, those are kind of the ones that are like separating someone getting like a 30 or above, right? Those last 10. That's where things happen. Now, there's another strategy I want to teach you here. They're telling us we've got a standard XY coordinate plane. A circle is centered here and passes through this point. It's a set of all points that are what? The technique for this is if they give you points, draw an axis nice and big. I'm going to draw my X and Y axis nice and big. Now they tell us one point is at 1, 3, the other one is at 4, 7. So 1, 3, that'd be over 1 and up 3. So there's 1, 3. The other one's at 4, 7. So over 4. So 1, 2, 3, 4, and up 7. 2, 3, 4, 5, 6, 7. Okay. Now this 1, 3, we're told that that's the center, right? So this is the center of the circle. And you remember all circles, they have a center point, and this is on the circle. So the circles, if I were to connect these, the circle's probably something, you know, something like that. Now, what I need to do is, if I look at my answer choices, it's, now this center point is, I'm sorry, I keep moving my camera over. This center point's at 1, 3. Now a circle are all the points on the outside here, all these points. So it looks like 5 coordinate units from, boy, this is a lot of wording here. What if we did this? What if we were to, this point here again is at 4, 7. What if we were to draw right triangle here? The height of the triangle would be the difference in the y values, which is 4. The length of it would be the difference in the x values, which goes from 1 to 4, which is 3. Do you see the 3, 4, 5 triple? So the circle, right? The circle are all the points that are 5 units away from the center. And if I look at the choices, letter F is the only one that says that they are 5 coordinate units from the center, which is 1, 3. And notice in the answer choices, they're not using the word center. They're kind of wording it a little differently. But by drawing a picture on this, and notice this also has Pythagorean theorem in it. It's got a triple in there. A lot of interesting things all tied in there. All right. That one's not too bad. We've got a few more minutes. Mr. Williams is going to get back here at 8:20. So we got about 12 more minutes. Let's look at number 50. Now we did a domain and range question yesterday or the day before. This is set builder notation, but it's the same idea. This is a function, and this is its graph. What are some numbers that that this function can never, ever use?
-1 and 3.
Yeah, you see the holes at 3, right? So I'm going to eliminate F because it doesn't say that you can't use 3. I'm going to eliminate G, and I'm going to eliminate K because none of those say it can't be a 3. Now the -1, that was really good. See, you've got to recognize that there's a vertical asymptote here that this graph cannot cross. And if you look at the choices, you know there's another one there, so it's got to be letter J. Got to be. That one. Don't want that. Nope. Talked about that one already. Did that. Okay. Can you all flip to number 36, please? Okay, 36. I'd like to give you a full minute on this one and have you work it out, okay? Yes, there is so much stuff going in this question. First off, they want to know what must be the measure of the central angle for a circle containing bananas. Now, they did say that peaches were chosen by the favorite of 15 students, and we can see that 15 people chose peach. And then apples, bananas, and strawberries were each chosen as favorites by an, here's the key right here, equal number of remaining students. So if I take the 90 students and subtract the 15 peaches from there, right, I'm going to get 75 students left. Now, those 75, they each chose an equal amount of apples, bananas, and strawberries. So if I just divide by 3, I'm going to get an answer of 25. Now, ACT is really nice and did not have 25 as an answer because some people might have chosen that. So what I want to do, there's a couple ways to do this one. One way is this. A circle is 360 degrees, right? And if I multiply that 360 degrees by the part that like bananas, which is 25 out of 90, right? 25 out of 90 like bananas. I take that, that gives me a fraction, multiply it by the 360, I'm going to get 100. So I thought that was kind of a nice one. We have not seen one like that. Go ahead. Question, Sam? No? Okay. Can you guys go to number 25? I think this one looks a little familiar. We did one like this yesterday. I'm going to give you 25 seconds. You don't get any more than that. All right, this is 5 out of the 6 pieces, and this is 3 out of the 4 pieces. Here is E. So yeah, this is a total, like you could tell, it's a recycled question. ACT's asked a question like this earlier. They do that a lot. Let's look at another one. We did some domain questions. Let's look at number 20. This is a range question, but it's in terms of a graph, right? Remember, range, that's the Y values. What are the Y values in between? Well, that's like, how high does this graph go? It goes about this high. How low does the graph go? About to there. Well, I think I could safely eliminate F, right? Because -5, I don't think so. Letter G, -2, probably, but it only goes up to 2. No, this goes way beyond. I don't think so. Here, -2 to +8. That might be it. Letter J, 3 to 8? No. 3 to 10? No. Yeah, it's got to be letter H. So that was a nice range question. Now, we have not done one of these questions that groups them together. So I would like for you all to, this is what we're going to finish on because Mr. Williams will be back here in about 5 minutes. I would like you to go to number 29, and I want you to do, get this big picture here. I would like you to do 29, 30, 31, 32. These 4 questions all go with this. All right. Now, in the interest of time, I'm going to give you 4 minutes to do it. You may begin. Mr. Williams, we're just working on our last section here. We're going to finish this with in about 40 seconds, and then I'm going to go over the answers and I'll turn them over to you.
Sounds good.
Good deal. Are the Chiefs ahead or behind? I've not been watching.
They just tied it up. 7-7.
Oh, they're 7-7. I was relieved when Mahomes made the final roster. I thought he might not make the cut. I was glad they announced that he made the team.
I think he's the highest paid player in sports history right now.
Yeah, $500 million.
Yeah.
Okay, that's it. Now that would be if you were to stack $1 bills one on top of the other. It'll go halfway to the moon, I believe. I got to look at the math on it, but I think it'll get really far. Okay, let's look at this. Let's go through number 29 first. It says, what is the area in square units of ABCD? So ABCD. This is a parallelogram. How do you find the area of a parallelogram? Base times height. The length is 5. The height is 3. What's 5 times 3? 15. Some people don't remember a parallelogram's area is just base times height. It's just a rectangle that's been kind of pushed over a little bit. This one says, what's the distance from B to D? So we're trying to go from B to D. So what I did was I drew the right triangle for that. Like if I were to just cover this piece up here, here's our right triangle. It's in purple. How tall is it? 3. How long is it? 4. Pythagorean triple. I'm telling you, they love these triples. 5. Done. Don't even memorize the distance formula. It's not worth your time. And then number 31, what's the slope of BC? Well, I think BC is a horizontal line. It's got no slope at all. Not going anywhere. And then 32, if you were to reflect the parallelogram over the y-axis, where would A go? So imagine this is on a mirror, right? If I reflect it over the y-axis, the stuff over here goes there. The stuff on the left side goes here. Where would A go? I think A is a distance of 1 away from the mirror. So when it comes over here, it's going to be at the point 1, 1, which is J. All right. Any questions at all? I think Mr. Williams is getting ready to tell you all to kind of stand up, stretch a little bit, get the blood going, get a drink of water, use the bathroom. How much time, Mr. Williams? What do you think? A minute?
Yeah, 60 seconds is good.
All right. I'll put it on my timer.
And then go ahead and stop screen sharing whenever you're ready. Oh, actually, I guess after the minute is fine. Done.
Well, you know what I need to do, though? I need to